All right, ladies and gentlemen, thank you for joining us for Virtual Mountain Connect. My name is Zach Hubeck with Wave LLC. And in this 30-minute segment, we're going to talk to a great group of thought leaders from Cambium Networks as well as Wave LLC on the benefits of multiband backhaul. So in today's environment where we're trying to connect so many people to the internet, there's a lot of different physics environments, and there's a lot of reasons for a certain technology to be used. And the fine folks on the line today with me absolutely believe in the benefits of multiband backhaul. We're going to be talking through all of that. We're going to go everywhere from what is multiband backhaul to what is rain fade, and we're going to solve all these things today for everybody. So we're sorry we can't be in person at Mountain Connect, but the first thing I want to do is go right through our entire group of panelists this morning. I'll start again. I'm Zach Hubeck with Wave LLC. I'm the VP of Sales and Marketing, and I've been in my seat for about 21 years. So let's go reverse alphabetical by middle name. I'll jump to Jason. Jason, who are you?
Hello, my name is Jason Petrillo, and I'm the Senior Product Evangelist for the infrastructure team at Wave, and I've been in the industry about 30 years.
All right, next up, Steve.
Hey everybody, I'm Steve Kiley. I'm with Cambium Networks. I've been with Cambium for about 6.5 years, and I'm the Regional Sales Manager for the Rocky Mountain Midwest.
All right, Mark.
Hi everybody, I'm Mark Billets. I'm Senior Sales Engineer at Wave. I've been with Wave for about 4 years, and I've been in the industry for about 20.
All right, Peter, how about you?
Hello, Peter Cousins, Senior Director of Business Development. I've been with Wave for 7.5 years and selling wireless solutions for 15 years.
Awesome. And finally, Matt.
Matt Musial here. Thank you for joining. I'm a Wave business development guy, and I've been in the wireless business for 30 years.
Awesome. Very cool. Matt, I warmed you up and saved you for last because first question is for you, brother. So let's talk about multiband backhaul. We're here to talk about the benefits of multiband backhaul. Why don't you just take the group through what is multiband backhaul?
So multiband backhaul is relatively new in some respects, and other respects not. Basically, what it is a millimeter wave link and a microwave link down the same path, providing the peace of mind of microwave and the uptime of microwave, yet the capacity of millimeter wave.
Ooh, big pipe. We're happy about that. Steve Kiley, do you want to expound on anything Matt said there? What is multiband backhaul? How does Cambium play in that segment?
Yeah, so we have a couple different solutions. We've been doing it for a long time. One of the things that we're able to do is we can have a licensed microwave plus a millimeter wave radio go down the same dish. So if you've got a tower that you're paying rent on, you can actually save yourself quite a bit of money, quite a bit of real estate by doing that same dish with two different technologies going down it. But as Matt said, it's the reliability of licensed microwave coupled with the high capacity of millimeter wave.
Very cool. Mark Billets, why don't we jump over to you, sir? I heard reliability. I heard real estate. Thought of any other benefits on why it's important to embrace multiband backhaul? Is there anything the fellas missed?
I don't think there's anything they missed, but let's expound on that. So what does it do? So we have the millimeter wave, which is your really big capacity pipe. And then we've got the microwave, which is not quite as big, but we're melding the two together so that we can increase the distance of the millimeter wave, okay? Typically, we have distance limitations on millimeter wave, and it's just a function of the frequency. But if we add a microwave link behind that, we can increase the distance and still keep the uptime.
Can you get a little more specific there, Mark? So millimeter wave, for those folks that may not know at Mountain Connect, millimeter wave, you're getting, estimated. And of course, site surveys are important and all those things. But estimated, what are you getting out of millimeter wave versus a microwave?
Okay, so millimeter wave, in this instance, we're talking 80 gigahertz. The microwave would be either an 18 gig or a 23 gig. On the millimeter wave, we have capacity of up to 10 gig, okay? And then on the microwave link, let's say roughly 600 meg, okay?
Got it. And so that 10 gig pipe on that millimeter wave, the furthest shot you're going to get with that is, in your estimation, is what?
Well, that's a question everybody asks. It's a tough question to answer, but let's go in generals. With decent availability on millimeter wave standing alone on its by itself, we're looking right around 2 miles. Okay, if we add the license to it, we can go 3 miles, maybe 4 miles, maybe even a little more. We'd have to look at the path. Okay, but so we can take the hit on the availability on the big pipe, but keep connection going with the microwave portion.
Awesome. Jason or Peter, anything you want to expound on what the fellows talked about there in regard to distance or throughput? Or no?
I would say that there are varying degrees of success with far distances than the 2 mile, but 10 gig option then is decreased substantially. So in an instance where you're going to use this as an alternate to a fiber connection or a backup to something else, you can still get multiple gigabits greater than 2 miles. You just are going to lose to the distance and rain fade potentially. So
got it.
Yeah, it's a tough question for sure. We've got a lot of WISPs that we work with, and we've got WISPs shooting 10 to 11 miles. So you've got to kind of balance that availability with the distance, and then also you have to pay attention to the rain region that you're in. And so, if your customers are okay, or you're okay with having your link down for 30, 45 minutes out of the year, then you can actually stretch it a pretty far distance.
Nice. So we're getting a little bit into my next question, guys, and Peter will ask this of you. And so as far as limitations, and we use the phrase there, rain fade. Can you talk a little bit about what rain fade is in a millimeter wave environment and why it's important?
Sure. Thanks, Zach. Rain fade is simply interference caused by weather and moisture in the atmosphere. And due to the nature of the millimeter waves themselves, there's a greater effect on the distance that the waves are able to travel. It's purely back to the physics and the characteristics of millimeter wave versus other licensed or other frequencies in general. And that's why you have rain fade that affects millimeter wave versus other licensed frequencies like 11 or 18 or 23 gig.
So a very intelligent manufacturer would engineer a great product that would not only have millimeter wave radios in it, but also the licensed radios in it as well to help mitigate, not completely eliminate rain fade, but to mitigate that. True statement?
Sure.
I think that is true. And I think, we touched on it briefly, but I just want to reiterate that one of the interesting ideas about the solution today is that you're using one antenna for both frequencies, which is really capitalizing on less lease costs on the tower. Whereas not too recently in the past, you would have to have two complete different antenna solutions to support each frequency. Today, you're combined into one antenna, which allows you to have both types of radios transmitting across one link of radio or of antennas.
Very cool. You're getting a little bit into like total cost of ownership, things along those lines. There's just all sorts of benefits downhill when we're seeing these radios combined. One antenna, both frequencies, extremely valid point. Mark Billets, can you talk a little bit more about the rain fade, the rain effect, one geography versus another? Have you seen anything in your days where millimeter wave was affected and could have benefited a multi-band backhaul solution like Cambium offers?
Sure. So if we're looking at putting a link up in, let's say, Arizona, Obviously, there's not a lot of rain, so we don't have any effect there. But let's just fly a little bit east. If we went to, say, Houston, Texas, they get some pretty heavy rain there, or New Orleans, and that'll definitely limit the distance that you can design on a millimeter wave link. If we had failover to licensed microwave 18 or 23 gig, we could definitely stretch the distances or keep the availability up, or both, in one of those situations, like in Houston or New Orleans.
All right, very cool. So guys, a question about the licensing real quick. I know 1823 gigahertz is licensed, but when we start talking about millimeter wave, I believe that's lightly licensed. Correct me if I'm wrong. But how would that work in this multi-band backhaul environment? Would you need to get FCC certification? Who wants to grab that question?
I'll take it. So they're going to have 2 licenses per link, essentially. And the first and most important license that you're going to look for is your and generally we're going to use 18 or 23 gigahertz, because we're generally in a short-ish distance, 5 miles or under. It could be longer links where 11 gigahertz you might want to use 11 gigahertz, but in that case you would have to use a separate antenna. But if we're speaking of a 18 or 23, we're going to want to get a PCN going for the 18 or 23 gig licensed microwave shot, and providing that we have clearance on a PCN for that shot, then we can the millimeter wave light license is very easy and very quick to get. So I would do it in that order: licensed microwave shot first, get the PCN going, and then start the process for a millimeter wave link, which is $75 for a 10-year license.
Nice. I like it. Good advice for the group. Awesome. So guys, let's use a big industry trend and phraseology, marketing fluff, whatever you want to call it, 5G. Okay, guys. So how does multi-band backhaul, why is that key to 5G installations worldwide? Who wants to grab that one?
I'll take it from an international perspective, and from my time in the millimeter wave space. 5G in the United States could be the amount of capacity you need for a 5G base station can be facilitated in most cases with a fiber connection. Okay, the fiber density has gotten to the point where the 5G sites, macro or small, are on a fiber link. That is going to be the case for about 80% for carriers like Dish, Verizon, T-Mo, and those guys. The other 20%, and largely overseas where fiber is not as prevalent, we need to get a big pipe to 5G base stations. And we can do that with millimeter wave, but not with microwave in most cases. So if a carrier, a 5G carrier, or a private 5G, private LTE or 5G user needs to get capacity a couple of miles, 5-6 miles from a tower, millimeter wave may be the only way to do it. But since you want that peace of mind and you need those customers up as much as possible, then that microwave backup or fill in, as it were, it's not a hard cutover, remember, from millimeter wave shot to a microwave shot. This is a layer 1 aggregation fill in. So you get that uptime and you don't have a handoff or downtime when the rain comes and the link switches from millimeter wave to microwave. So 5G people are very excited about this technology.
Awesome. Love it. Why don't we bounce around to Jason, Steve, or Peter? You guys can take this. Can you think of any other applications where you've seen a licensed 18 or 23 gigahertz environment that could use millimeter wave, or vice versa? Have any specific applications come to mind and use cases that you've seen be successful in your time in the seat? Who wants to go first?
I can go first if it's okay.
Yeah, we'll go Jason. Then Steve, you're on deck, brother.
Okay. So one of the recurring themes with the 10 gig link is in nuclear medicine or imaging, where you need lots of data between short distances, but usually on a campus situation or environment. And the 10 gig link or the 80 gigahertz link becomes your primary link where fiber is not reasonable to run, and then your backup link becomes that 18 or 23 gig. And realistically, it's not just limited to 18 to 23 gig. You could in a pinch use 11 gigahertz, or maybe even 13 or 15 or 7 gigahertz if needed. So there are different options available there. But that's those imaging environments, that's where I've seen it most often requested.
Nice. Steve, why don't you go ahead next?
Sure. Yeah, one of the more popular ones, and Peter and I worked on one earlier, is that with the fires that are going on, you'll get a lot of fiber that's melted, or even melted in the ground. So these fires get really hot, and that's where they need a really quick deployment. They need a lot of capacity because the fiber's been cut, and that's where these multi-band radios would come in, where you can still have some reliability, but maybe stretch the shot a little bit with millimeter wave and still get those people connected.
Nice. Peter, how about you, sir? Can I lob one over to you? Or
yeah, absolutely. And kind of taking Jason's example further, you could see something in security where you're backhauling a video surveillance deployment, where you have maybe a millimeter wave multi-point system out to a series of cameras, and you want high resolution, high quality video, and you don't want to bottleneck at your backhaul back to a fiber pop. You could use this type of multi-band system for a short backhaul site or shot back to the fiber location itself.
Nice. And I think, one of the things that always sticks with me, Matt, when he came on board with Wave here, he did this training about millimeter wave. And what was absolutely flabbergasting to me, gentlemen, was I think it was 2,500 links within a 3-mile radius in San Francisco. And Mark, could you talk to the group a little bit about the benefits of how much density you can have in an urban environment with millimeter wave, with licensed frequencies, and how it's going to mitigate interference for those users?
Well, so with millimeter wave in particular, because of the characteristics of the frequency, it doesn't interfere with itself because it just dissipates. And then to add on top of that, we've got very, very narrow beam width on the antennas, okay? So they don't see each other. So it's really good in those high density environments.
Awesome. Matt, do you want to expound on that a little bit more?
Yeah, Mark hit the nail on the head. Narrow beams and the propagation characteristics, the physics essentially for millimeter wave lends to very, very high density. A customer of mine at a former gig had 57 links emitting from the same rooftop in New York City, for example. Wow. 57 links to 57 remote locations, to give you an idea. So when you take the entirety of Manhattan or Brooklyn or Queens or San Francisco and places like that, where fiber's very, very expensive and not so reliable in some cases, you can pretty much throw the kitchen sink at 80 gigahertz and put as many links in as you want.
Beautiful. I love it. So guys, we talked a little bit about quick deployments. There was a reference to the wildfires that are going on right now. A lot of you guys are in Washington State or Colorado, and in Mountain Connect. If we were having Mountain Connect, it would be in Colorado. But we talked about the need for these very easy to deploy quick links when fiber is literally melted into the ground. Let's talk a little bit about the total cost of ownership in just a normal environment. Millimeter wave and microwave versus fiber. Whoever wants to take that question about the total cost of ownership, fiber versus this multi-band backhaul, who would like to take that one?
I can step in there real quick. Sorry, I had to switch to my cell phone, but I've got several WISPs that deploy fiber and fiber wireless, and so we get a lot of feedback on ease of deployment of wireless versus fiber. So when you talk about total cost of ownership, the planning that it takes and all of the different regulatory environment, everything that goes into deploying a fiber network, whether it's aerial or buried, can be fairly expensive compared to just planning getting onto a vertical asset and running wireless. And then what I've learned a lot about is these fiber networks where they have these handholds, and these handholds are basically where you splice your fiber that goes to the residence or the business off of your main trunk. Excuse me. And when you look at those handholds, and where they put them, sometimes they have to get creative on how to get back to them. So all in, not to get too lengthy with the answer, I've heard people throw out the number of, in general, you're looking at like $30,000 per mile for fiber, regardless of the environment that you're in. I know some guys have gotten creative and gotten that cost down, but then when you look at deploying a mile link of a 10 gig link with wireless, you're typically talking about something in and around the neighborhood of $14,000 to $20,000. So fiber and wireless, the wireless is quick to deploy, and typically it's quite a bit less money to deploy it.
And Steve, really, you're focusing exclusively on the technology aspect. All of the things in a fiber deployment, you're talking about permitting and construction and trenching and easements, that need to be considered with existing residential areas in certain environments. So all of that needs to be factored in from a project management standpoint. It does seem that multi-band backhaul is a little bit easier than a fiber deployment. Fair statement, guys? Would you agree with that?
Yeah, absolutely.
Yes,
I mean, you start
absolutely.
to talk about pole attachments and pole upgrades and things that you may have to do. The price just goes up.
Right on. Good. Well, Mark, I'm going to lob a question over to you, being on the engineering side at Wave.
Sure.
What are things people need to consider when they're looking at multi-band backhaul? What are some of the things they need to consider from a project basis? And how can Wave help in the equation if people want to get started and haven't done this before?
Sure. So that's a good question, Zach, and I'll expound a little bit. So we're still looking for if it's a point-to-point, we need clean line of sight. So we can't really have obstructions in the way, buildings, trees, hills, or anything like that. And that's especially true the higher we go on the frequency. So we want clean line of sight. From an engineering standpoint, if you've got an application, Wave Engineering would be delighted to take a look at the application and run a path analysis for you. That's something we'll do for free, and we've got really good experience with that. So what I would need from a prospective deployment standpoint would be either addresses or GPS coordinates for both ends, and then anticipated heights of the antennas. And then tell me what data rate you want, and we'll take it from there for you.
All right. Love it. Kylie, talk about the engineers at Cambium. What kind of support do folks have, not only with Wave, but also upstream at the manufacturer level with you guys? How do you help?
Yeah, absolutely. Cambium's developed several tools. One of them that's been in a long time use is Link Planner. And so Link Planner is a free tool that allows you to do basic network design and modeling. But then we've also enhanced it with a new tool called See and Heat. And See and Heat's very accurate. We talk about mmWave and the fact that it needs line of sight. And with See and Heat, we're using LiDAR data. So it's very, very accurate, down to 1 meter accuracy. And it allows us to tell customers with a very high probability of success that they have line of sight in areas. Then they can use that data, put it into Link Planner, and then they'll give you what Mark referenced, the number of nines of reliability. It gives you a total bill of materials. So then Wave can quote that out. And it also gives you an installation report. So you can drop that installation report with your installers, and they'll know what the azimuth heading is, what the signal strength should be, and so on. So Cambium tries to do as much as they can to offer value and help out our distributors like Wave, kind of do a one-stop shop and help the customer have everything that they need, make it real easy.
All right. Awesome. Very good. So gentlemen, I want to thank you for the time. I think this has been just a great session. Anybody have any closing thoughts on Mountain Connect? Any well wishes to the folks that would be in attendance if they were physically stopping by the booth? Any closing thoughts on multiband backhaul benefits? Anything we didn't cover at this point?
I'd just like to add, yeah, since we're talking about Colorado and the mountains here, snow does not affect millimeter wave. This is one, just rain. So rest assured, it works well when everything's frozen. The second thing I'd like to add is that even if your intent is to deploy fiber, if you anticipate there's delays, right of ways, you have to get over the BNSF railroad tracks, or even if you just want to back up for that critical link, use millimeter wave or multiband links as a quick to deploy while you're doing your fiber project. It's a great stopgap. It's leave it in as a backup. Once your fiber's in, they play well together. I call it hybrid fiber wireless.
I think a great point to make there, Matt, is we want to reach this certain area with a fiber ring. And we can't monetize that network yet. How do we monetize that network while we're still getting permits, while we're still building out our fiber? Look to multiband backhaul as that bridge to get there, if you will.
Exactly.
Awesome. Anybody else?
Oh, this is Peter. I just wanted to say thanks to Mountain Connect, and fingers crossed that we get to see everybody in person next spring.
Absolutely. All right, guys. Anybody else before we wrap here? All right, folks. Well, if you do have any questions for any of our panelists or Wave or Cambium, we are going to be at the show virtually. So it's as if we were in the booth. If you have questions, please do submit those to us and we will address those. We've got folks that are going to be live on the day of the virtual event who are going to absolutely answer any questions you may have. And we will absolutely get back to you. Peter is going to be there, so he'll be answering questions live for the group and sharing best practices and not cutting your head when you shave. So thank you guys so much. It's great to see you all. And then folks at Mountain Connect, thank you for having us. And attendees, we wish we were there. We will see you soon. And thank you guys so much for your time today.
All right. Thank you.
Bye all.
Bye-bye.
Thanks all.